So well, so today we are going to start a new topic, and this topic is very important for all branches of engineering. And this topic is infinite series. And today we will discuss first what is the importance of these type of series, then how can we define these type of infinite series, and what is partial sum. Then we will discuss a very important test, and that test is geometric series test. And finally, we will define what is positive term series, because these infinite type of series have two types. First one is positive term series, and second one is alternating type of series. So today we will discuss what is positive term series. So differential equations are frequently solved by using these type of infinite series. Fourier series, Fourier Bessel series, etc. Expansions involve infinite type of series. Even transcendental functions like trigonometric, exponential, logarithmic, hyperbolic, etc. can be expressed conventionally in terms of infinite series. Many problems that cannot be solved in terms of elementary functions like algebraic functions or transcendental functions can also be solved in terms of infinite series. So, in other words, we can say that infinite series occur so frequently in all types of engineering problems that the necessity of studying their behavior, like convergence or divergence, is very important. So, unless a series employed in an investigation is convergent, it may lead to illogical conclusions. Hence, it is essential that the students of all branches of engineering begin by acquiring an intelligent grasp of this subject. So, these are few importances of this type of series. So, let us define how can we represent infinite series. So let us define what is infinite series. Let un be a sequence of real numbers. Un be a sequence of real numbers. This means that we can represent un like this way. Un, u1, comma u2, comma u3, u4, un, and so on up to infinity be a sequence of real numbers. So we can represent this notation like this way. u1, u2, u3, u4, and so on, un, and so on up to infinity. Then question is, how can we represent this type of series, means infinite series? So then the expression u1 plus u2 plus u3 and so on, un plus and so on up to infinity means sum of each element, sum of every element. That expression, that is the sum of the terms of the sequence, which are infinite in number, is called an infinite series. Is called an infinite series and is denoted by summation n1 to infinity un, or more briefly by summation un. So this means that this expression, sum of the terms of the sequence, which are infinite in number, is called infinite series. तो हमें इस कंप्लीट जो टॉपिक है इनफाइनाइट सीरीज का, हमें ये जो एक्सप्रेशन आपने लिखा है u1 प्लस u2 प्लस u3 प्लस un एंड सो ऑन अप टू इन्फिनिटी, इसका बिहेवियर को एग्जामिन करना है, examine the behavior of these type of series, whether these type of series is convergent or divergent or oscillatory. We have to examine all these things. So next definition is what is nth term. देखिए ये आपके पास एक सीरीज है, this un is the nth term. Okay, the term un in an infinite series is called the nth term of the series. अब देखिए यहां पर इनफाइनाइट नंबर ऑफ टर्म्स है. अगर नंबर ऑफ टर्म्स आपकी फाइनाइट होंगी, देन वी कैन से दैट दिस सीरीज इज फाइनाइट सीरीज. And if the number of terms in the series is infinite, then the series is called infinite series. So next definition, finite series. If the number of terms in the series is limited, means finite, then the series is called a finite series. And infinite series is if the number of terms in the series is infinite, then the series is called an infinite series. So this all about definition of infinite series. Now one more definition, and that one is very very important for examining the behavior of these type of series, and that definition is nth partial sum. So what is nth partial sum? The sum of first n terms. The sum of first n terms of the series is called its nth partial sum of summation un, and that nth partial sum is denoted by Sn. Sn. Clear? The sum of first n terms of the series is called its nth partial sum of summation un and is denoted by Sn. That is, Sn can be written as u1 plus u2 plus and so on plus un. So Sn is represented by this. अब देखिए जब आपके पास इस ये जो एक्सप्रेशन आपने राइट साइड लिखा हुआ है, अगर आपके पास एक ही टर्म है तो S1 क्या होगा, u1 होगा. जब हमारे पास दो टर्म्स होंगी तो S2 क्या होगा, u1 plus u2 होगा. When we have three terms, then S3 is S1 plus S2 plus S3. So when we have n terms, then Sn is u1 plus u2 plus u3 and so on plus un. This means that Sn is a function of n. Sn is a function of n. And as n increases indefinitely, then the following three cases arise for discussion. Okay, so this Sn is a function of n, and as n increases indefinitely, then the following three cases arise for discussion. Number one, very important. If Sn tends to a finite limit as n tends to infinity, if Sn tends to a finite limit as n tends to infinity, then summation un is convergent. This one is the definition of convergent of a series. So if Sn tends to a finite limit as n tends to infinity, this means the given series is convergent. This means we have to evaluate limit n tend to infinity Sn. If this one is finite, then the given series is convergent. तो जब भी आपने बिहेवियर कैलकुलेट करना होगा किसी भी इनफाइनाइट सीरीज का, तो सबसे पहले आपको nth पार्शियल सम लिखना पड़ेगा. What is nth partial sum? And then taking limit. Limit means n tend to infinity. If limit n tend to infinity Sn is equal to finite value, finite limit, then we conclude that the given series is convergent. And second, if Sn tends to plus infinity or minus infinity, as n tends to infinity. If Sn tends to plus infinity or minus infinity, as n tends to infinity, then the given series is divergent. So this means that if limit n tend to infinity, Sn is equal to plus infinity, then the given series is divergent. Or minus infinity, then the given series is divergent. Clear? So these are the definitions of convergent and divergent. And third one is, if Sn does not tends to a unique limit as n tend to infinity. If Sn does not tend to a unique limit as n tend to infinity, then summation un is oscillatory or non-convergent. Is oscillatory और नॉन कन्वर्जेंट. तो देखिए ये जो केस नंबर 2 है, अगर मैं ये लिखता हूं इफ एस एन टेंस टू प्लस इन्फिनिटी एंड माइनस इन्फिनिटी देन द सीरीज इज ऑक्सिलेटरी. मैं यहां पर वर्ड यूज कर रहा हूं प्लस इन्फिनिटी और माइनस इन्फिनिटी, देन द सीरीज इज डाइवर्जेंट. तो अगर मैं एंड यूज कर रहा हूं दिस मीन्स दैट एस एन डज नॉट टेंड टू यूनिक लिमिट. वो प्लस इन्फिनिटी भी है और माइनस इन्फिनिटी भी है. So if Sn does not tend to a unique limit as n tend to infinity, then the given series is oscillatory. And always remember, any series which diverge or oscillate are said to be non-convergent series. Okay, so any series which diverge or oscillate are said to be non-convergent series. Let us discuss examples of each and every case. So first point is examine the behavior. First example is examine the behavior of this series. Obviously this one is an infinite series. Clear? This one is an infinite series. So first write the given series. Then first step is write nth partial sum, means write Sn. So how can we write Sn? Sn is equal to 1 plus 1 by 2 plus 1 by 2 square plus and so on nth term. So up to nth term we can write Sn. Clear? अब देखिए clearly this expression right expression is a geometric progression whose first term is 1. And what is the common ratio? Common ratio is 1 by 2. Then you can write Sn. By using this formula, a into 1 minus r power n divided by 1 minus r. So using this formula for evaluating Sn. So Sn is equal to, in this case, 1 into 1 minus 1 by 2 power n divided by 1 minus 1 by 2. Just simplify a right side. We get 2 into 1 minus 1 over 2 raised to power n. And you know, if Sn tends to a finite limit as n tends to infinity, then we conclude that the given series is convergent. So taking limit on both sides. Okay. So when we take limit on both sides, we get limit n tends to infinity Sn is equal to limit n tends to infinity 2 into 1 minus 1 over 2 raised to power n. तो जब आप पहली टर्म लिखोगे तो ये 2 1 माइनस, now 2 raised to power infinity is 0, नहीं 2 raised to power infinity is infinity, so 1 over infinity is 0, right? So we get 2. So when Sn tends to a finite limit, and this 2 is a finite limit as n tends to infinity, clear? Then the given series is convergent. Clear? The given series is convergent and converges to 2. Clear? So by using this method, okay, we can say that if Sn tends to a finite limit as n tends to infinity, then summation un is convergent. Now let us consider one example related with second definition. If Sn tends to plus infinity or minus infinity as n tends to infinity, then series is divergent. Let us consider example. Examine the behavior of the series 1 plus 2 plus 3 plus and so on plus and so on up to infinity. So examine the behavior of this series. So what is given series? 1 plus 2 plus 3 plus and so on and so on up to infinity. So first step, write Sn. Sn means nth partial sum. So in this case, what is Sn? Sn is 1 plus 2 plus 3 plus and so on plus n. And you know, sum of first n terms is n into n plus 1 over 2. Clear? N into n plus 1 over 2. Not taking limit on both sides. So when we take limit on both sides, we get infinite value, infinity. And you know, if Sn tends to plus infinity, as n tends to infinity, then the given series is divergent. Hence, the given series is divergent in this case. Clear? So this one is the example of second case. Okay. This one is the example which diverge. Diverge means tends to infinity. Okay. वो जो infinite sum है, that one is infinite value. And if infinite sum is finite value, this means the series is convergent. Now, let us discuss one more example which is oscillatory. That series is oscillatory. So if Sn does not tend to a unique limit, okay, as n tend to infinity, then summation un is oscillatory or non-convergent series. Now, examine the behavior of the series 1 minus 1 plus 1 minus 1 plus 1 minus and so on. And in compact form, this alternating series can be written like this way. Summation n1 to infinity minus 1 power n minus 1. So given series is this 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on, which can be written as summation n1 to infinity minus 1 power n minus 1. Now, first, write nth partial sum. So in this case, Sn is equal to 1 minus 1 plus 1 minus 1 up to n terms. Clear? Up to n terms. So when n is equal to 2m means even terms, like 2 terms, sum is 0, 4 terms, sum is 0. So when n is even terms, this Sn is equal to 0. And odd terms, then sum is 1. Means n is equal to, when n is equal to 2m plus 1 means odd terms, then sum is 1. So simultaneously, nth partial sum is 0 and 1, clear, for even and odd functions, odd number of terms. No problem, taking the limits on both sides. So when we consider limit on both sides, then limit n tend to infinity Sn is equal to 0 as well as 1. So we have two limits. And you know, if Sn does not tend to a unique limit as n tend to infinity, then the given series is oscillatory. So clearly in this case, Sn does not tend to a unique limit as n tend to infinity. Hence the given series is oscillatory, and in this problem oscillates between 0 and 1. And oscillates between 0 and 1. This completes the proof. Okay. So in this way, we can examine the behavior of these type of infinite series. तो हमने देखिए 3 एग्जाम्पल किए हैं. पहला एग्जाम्पल जो है वो कन्वर्ज कर रहा है, दूसरा एग्जाम्पल जो है वो आपका डाइवर्ज कर रहा है, ये जो एग्जाम्पल थर्ड एग्जाम्पल किया ये आपका ऑक्सीलेट कर रहा है. ठीक है. तो इन सारी प्रॉब्लम्स में आपने क्या देखा, आपको सीरीज दे रखी हुई है, आपने nth पार्शियल सम लिया और उसके बाद आपने लिमिट लिया और फिर रिजल्ट को देखा. If limit n tend to infinity Sn is finite, then the series is convergent. In finite value, then the series is divergent. And if does not tend to unique limit as n tend to infinity, then that infinite series is oscillatory. Okay. Now let us discuss one very important test, and that one is geometric series test. And the statement of this geometric series test is, show that the series 1 plus r square plus r cube plus and so on up to infinity, this series converges if magnitude r is less than 1. This means that when r in between minus 1 less than r less than 1, so when r lying in between minus 1 to 1, then this series is convergent. Okay. Now diverges if r is greater than as well as equal to 1, then the given series is divergent. And third, oscillates if r is less than equal to minus 1, then the given series is oscillates. देखिए हमने 3 एग्जाम्पल इससे पहले किए हैं। पहला एग्जाम्पल सिर्फ कन्वर्ज कर रहा है, दूसरा एग्जाम्पल डाइवर्ज कर रहा है, तीसरा एग्जाम्पल ऑक्सीलेट कर रहा है। और ये जो केस है, ये जो प्रॉब्लम है, ये कन्वर्ज भी कर रही है, ये डाइवर्ज भी कर रही है, ये ऑक्सीलेट भी कर रही है, बट डिपेंड अपॉन द वैल्यू ऑफ आर। ओके, डिपेंड अपॉन द वैल्यू ऑफ आर। क्लियर? So let us solve this very important test which is known as geometric series test. ये क्वेश्चन एग्जामिनेशन में इस तरह से पूछा जा सकता है, एग्जामिन द बिहेवियर ऑफ ज्योमेट्रिक सीरीज. सो फर्स्ट राइट द ज्योमेट्रिक सीरीज and write the conclusion. Okay, so prove those conclusions. First, convergent if magnitude of r is less than 1, divergent if r is greater than equal to 1, and oscillates if r is less than equal to minus 1. Now, first step is write nth partial sum. So nth partial sum means Sn. So in this case, Sn is 1 plus r square plus r cube plus and so on plus r power n minus 1. तो ये n minus 1 तक पावर को लेके जाना है, and that one is nth term of the series. Clear? So 1 plus r square plus r cube plus and so on plus r power n minus 1. And the sum of this geometric series is 1 minus r power n divided by 1 minus r. Okay, 1 minus r. And this sum can also be written like this way: 1 over 1 minus r minus r raised to power n divided by 1 minus r. So let us represent this expression number 1. Okay, तो अब हम इसको प्रूव करेंगे one by one. So case 1 is when we consider magnitude of r is less than 1. Then what is the limit? What is limit n tend to infinity Sn? So find the value of Sn as n tend to infinity in case when magnitude of r is less than 1. Now see, here Sn is equal to 1 over 1 minus r minus r raised to power n divided by 1 minus r. Sn is equal to this. Clear? Then as usual, taking limits on both sides. So when we take limit on both sides, we get limit n tend to infinity 1 over 1 minus r minus r raised to power n divided by 1 minus r. Now since r in between minus 1 to 1, suppose r is 0.5. So 0.5 raised to power infinity is 0. Even 0.9 raised to power infinity is 0. 0.9999 raised to power infinity is 0. So ultimately this whole term is 0, because 0 divided by something is 0. So we obtain only this term 1 over 1 minus r, and since r lying in between minus 1 to plus 1, not equal to minus 1, not equal to plus 1, but r in between minus 1 and plus 1. Clear? In between this, then 1 over 1 minus r is a definite quantity. And when we write here this one is a definite quantity, this means the given series is convergent. Okay, so this is only possible when magnitude of r is less than 1. Reason is because limit n tend to infinity r raised to power n, this is equal to 0. This result is equal to 0. Clear? So hence the given series is convergent if magnitude r is less than 1. So this one is the first part. Okay, so this geometric series is convergent if magnitude of r is less than 1. Clear? Now case number 2, when r is greater than equal to 1. So in this case we have two small sub cases. First one is when r is greater than 1, and second one is when r is equal to 1. Clear? So let us consider first case when r is greater than 1. Now what is Sn? Sn can be written as 1 over 1 minus r raised to power n divided by 1 minus r. Now this expression can also be written like this way: r raised to power n r minus 1 minus 1 over r minus 1. So we can represent Sn like this way also. Now taking limit on both sides. So when we take limit on both sides, we obtain limit n tend to infinity Sn is equal to limit n tend to infinity and within the bracket r raised to power n divided by r minus 1 minus 1 over r minus 1. This one is second term. Now since r is greater than 1, suppose 1.1 or suppose r is equal to, suppose r is equal to 9. So when r is 1.1 and after taking limit n tend to infinity, this term is infinity. This term is infinity. For every value where r is greater than 1, this term is infinite value. Clear? So infinite over something, infinite. Infinite minus something, infinite. So this tend to plus infinity. Clear? Reason is because limit n tend to infinity, r power n tends to infinity for r is greater than 1. And you know, when limit n tend to infinity Sn tends to plus infinity or minus infinity, then the given series is divergent. Clear? So this series is divergent if r is greater than 1. Clear? Now, second case, when r is equal to 1. So when r is equal to 1, what happened? What is Sn? Sn is very simple, 1 plus 1 plus 1 plus 1 up to n terms. And what is Sn? After taking sum is obviously n. Sum is obviously n. Now taking limit on both sides. So when we take limit n tend to infinity, Sn is equal to limit n tend to infinity n. And it becomes infinity. Clear? It becomes infinity. This means the given series is divergent if r is equal to 1. Clear? So combining both the arguments, we conclude that the given series is divergent if r is greater than equal to 1. And that one is the case number 2. Okay, we have already discussed in previous slide this one. Okay, and now this series is divergent if r is greater than equal to 1. Now let us discuss third case. Oscillates if r is less than equal to minus 1. Less than equal to minus 1. Again, we will discuss two cases, when r is equal to minus 1 and second when r is less than minus 1. So first case is when r is equal to minus 1. What happened? When r is equal to minus 1, then what is Sn? Sn is 1 minus 1 plus 1 minus 1 plus 1 minus 1 and up to nth term. Okay, so we can write nth term like this. So obviously when n is even, sum is 0, and when n is odd, sum is 1. So Sn is equal to 0 as well as 1. Clear? Sn is 0 as well as 1. 0 if n is even and 1 when n is odd. Taking limit on both sides. So when we take limit, we get two values. This means Sn does not tend to a unique limit. In this case, limit n tend to infinity, Sn is equal to 0 as well as 1. So this means that Sn does not tend to unique limit, okay, as n tend to infinity. Clear? This means the given series is oscillatory and oscillates finitely. Finitely means 0 and 1. Okay, so the given series is oscillatory and oscillates finitely. Clear? Now B part, when r is less than minus 1. Now let us suppose small r is equal to minus capital R. Okay, let us suppose r is equal to minus r, where capital R is greater than 1. Clear? Where capital R is greater than 1. And then find the value of small r power n. And that one is minus r power n, and that can be written as minus 1 power n r raised to power n. Now substitute these values in Sn and taking the limit. So limit n tend to infinity Sn is equal to limit n tend to infinity 1 minus r raised to power n divided by 1 minus r. Substitute the value of r, this, and r raised to power n. So we obtain this value. We obtain this value. And Sn, you know, 1 minus r raised to power n divided by 1 minus r. अब देखिए यहाँ पर क्या होगा. Capital R is greater than 1. Okay. Let us suppose r is 2. Capital R is 3. Capital R is 4. And as n tend to infinity, this term infinity. Clear? this term infinity, and minus 1 power n. So if n is even, it becomes minus. It becomes minus. So minus infinity. This complete term is minus infinity. So 1 minus infinity is minus infinity. So minus infinity over something is minus infinity. This means that this sum is minus infinity if n is even, and plus infinity if n is odd. This means Sn does not tend to a unique limit as n tend to infinity. Hence, the given series is oscillatory and oscillates infinitely. And oscillates infinitely. जो A केस था इसमें oscillates finitely. But in this case, oscillates infinitely. And this completes the proof. So the given geometric series 1 plus r square plus and so on up to infinity converges if magnitude of r is less than 1, diverges if r is greater than equal to 1, oscillates if r is less than equal to minus 1. Let us discuss few problems. Examine the behavior of this series. We get infinite series. Okay. So what is given? Given is summation un is equal to this. अगर आप इसको बारीकी से देखोगे तो जो Sn nth पार्शियल सम है वो आपका जीरो होगा अगर तीन नंबर्स आप लेके चल रहे हो, तीन टर्म्स लेके चल रहे हो, 3, 6, 9 इस टाइप की टर्म्स लेके चल रहे हो. मीन्स व्हेन n इज इक्वल टू 3m सम इज 0, 6 minus 10 plus 4 sum is 0. Sum is 6 if n is 3m plus 1. Sum is minus 4 if n is 3m plus 2. So this means that Sn is 0 as well as 6 as well as minus 4. So taking limit on both sides, we get these three values 0, 6, minus 4. Clearly implies Sn does not tend to a unique limit as n tend to infinity. This means the summation un is said to be oscillatory. Summation un is said to be oscillatory. Clear? Now one more example. Examine the behavior of this series 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus and so on. Now clearly this one is a geometric series in which first term is 1 and common ratio is r 1 by 2. So magnitude r is 1 by 2 which is less than 1. So when r is 1 by 2, this means magnitude of r is less than 1, then by geometric series test the given series is convergent. The given series is convergent. So in this way we can apply geometric series test in few problems. Okay. देखिए ये जो इनफाइनाइट सीरीज है अभी तक जो हमने स्टडी किया है, हम ये कहेंगे कि अगर आपको बिहेवियर इवेलुएट करना है तो आपको nth पार्शियल सम पहले लिखना पड़ेगा. ठीक है. nth पार्शियल सम मीन्स सम ऑफ फर्स्ट n टर्म्स. और आपने देखा होगा कि अभी तक जितने भी एग्जाम्पल्स किए हैं हमने, चाहे वो पहले 3 एग्जाम्पल्स की बात करें या इवन ज्योमेट्रिक सीरीज की बात करें, आप Sn को कैलकुलेट कर सकते हो. वो स्टैंडर्ड सीरीज थी. लेकिन ऐसा नहीं है कि हर प्रॉब्लम में आप Sn कैलकुलेट करो या कर पाओगे, ये जरूरी नहीं है. बहुत सारी ऐसी सीरीज हैं जहां वो जो स्टैंडर्ड सीरीज नहीं है, आप Sn कैलकुलेट नहीं कर पाएंगे. अब क्वेश्चन ये है कि जब आप Sn कैलकुलेट ही नहीं कर पाओगे तो फिर लिमिट लेने की तो बात ही नहीं आएगी. लिमिट तो आप ले ही नहीं पाओगे. जब Sn ही आपको पता नहीं है फिर आप लिमिट कैसे लोगे? ठीक है. तो क्वेश्चन ये उठता है कि अगर आप Sn नहीं लिख पा रहे हो, फिर उस केस में आप बिहेवियर को कैसे एग्जामिन करोगे? क्योंकि हमारी जो डेफिनेशन है वो तो ये कहती है कि इफ Sn tends to a finite limit as n tend to infinity, then the given series is convergent. If Sn tends to plus infinity or minus infinity as n tend to infinity, the series is divergent. And if Sn does not tend to a unique limit as n tend to infinity, then the series is oscillatory. तो इसका मतलब ये जो बेसिक डेफिनेशन है दैट बेस्ड अपॉन nth पार्शियल सम, that based upon nth partial sum. Now question is where we cannot evaluate nth partial sum, then how can we evaluate this type of behavior? ओके तो उस टाइप की प्रॉब्लम्स में बिहेवियर इवेलुएट करने के लिए हमारे पास कुछ टेस्ट हैं. हम उन टेस्ट की हेल्प से without evaluating SN, okay, by using those tests we can examine the behavior of these type of series. Okay, so before we discuss few tests for convergence or divergent or for oscillatory cases, let us define what is positive term series. So a series in which all the terms after some particular term, this point is very, very important. After some particular term are positive is called positive term series. For example, -5, -3, -1, +1, +3, +5, +7, and so on infinity. So all the terms after these three terms are positive. So that one is a positive term series. That one is a positive term series. और अगर आप इन तीन टर्म्स को रिमूव भी कर दोगे तब भी कोई फर्क नहीं पड़ेगा. फिर आपकी सीरीज बनेगी 1 + 3 + 5 + 7 एंड सो ऑन. अगर आप +1 + 3 को भी एलिमिनेट कर दोगे, दो टर्म्स को एलिमिनेट कर दोगे तब भी कोई फर्क नहीं पड़ेगा. आपकी सीरीज बनेगी 5 + 7 + एंड सो ऑन. तो देखिए, अगर आप कुछ टर्म्स को यहाँ से एलिमिनेट भी कर रहे हो, ठीक है, तो आपके जो बिहेवियर है, जो सीरीज का जो बिहेवियर है, उसमें कोई चेंज नहीं आने वाला. इफ यू ऐड फ्यू टर्म्स in an infinite series, or if you delete few terms from an infinite series, then behavior cannot be changed. अगर ये सीरीज कन्वर्ज करती होगी तो डिलीट करने के बाद भी कन्वर्ज करेगी. अगर ये सीरीज डाइवर्ज करती होगी तो डिलीट या ऐड करने के बाद भी वो डाइवर्ज ही करेगी. डाइवर्ज का मतलब क्या? इन्फिनिटी है. अगर आप कुछ टर्म्स ऐड भी कर दोगे तो क्या फ़र्क पड़ेगा. और अगर फाइनाइट है तो कुछ टर्म्स ऐड करने से, ठीक है, तो वो जो लिमिट है वो फिर भी फाइनाइट ही रहेगी. तो हमारा पर्पज़ सम निकालना नहीं है, हमारा पर्पज़ है बिहेवियर को इवैल्यूएट करना कि वेदर द गिवन सीरीज इज कन्वर्जेंट और डाइवर्जेंट और ऑक्सिलेटरी. तो हम दो टाइप की सीरीज को डिस्कस करेंगे. फर्स्ट वन इज पॉजिटिव टर्म सीरीज एंड सेकंड वन इज अल्टरनेटिंग टाइप ऑफ सीरीज, जहाँ एक टर्म पॉजिटिव है, नेक्स्ट नेगेटिव है, फिर पॉजिटिव है, फिर नेगेटिव है. उस टाइप की सीरीज को हम अल्टरनेटिंग सीरीज बोलेंगे. ठीक है, तो अल्टरनेटिंग सीरीज का जो बिहेवियर है वो एक पर्टिकुलर टेस्ट है, उसी टेस्ट से हम एग्जामिन करेंगे एंड दैट टेस्ट इज नोन एज लिबनिटीज रूल. सो विद द हेल्प ऑफ लिबनिटीज रूल वी कैन एग्जामिन द बिहेवियर ऑफ अल्टरनेटिंग टाइप ऑफ सीरीज. बट एज फार एज पॉजिटिव टर्म सीरीज वी हैव मेनी टेस्ट्स, ठीक है. वो टेस्ट जो 7-8 टेस्ट है वो हम नेक्स्ट 4-5 लेक्चर्स में, 4-5 प्रेजेंटेशंस में डिस्कस करेंगे. So all those lectures are very, very important. So today we have discussed importance of infinite series. Then we have discussed what is the definition of infinite series and how can we define nth term test. Then definition of nth partial sum. What is finite series? What is infinite series? And then discussion of convergence, divergence and oscillatory cases with the help of examples. Okay. Then finally we have discussed the behavior of geometric series and then we have solved 2 problems. Okay, and next time we will discuss 3 important tests. Okay, test for convergence and divergence of a infinite series. So first test we will discuss what is nth term test, second what is comparison test, and third what is p series test. तो हम जब भी ये टेस्ट हम देखेंगे, ठीक है, तो उन सारी प्रॉब्लम्स में आप नोट करना कि आप एसएन कैलकुलेट नहीं कर पाएंगे. ठीक है, तभी हम इन टेस्ट की हेल्प से बिहेवियर को हम एग्जामिन करने जाएंगे. ओके, सो फर्स्ट वी विल डिस्कस दीज 3 टेस्ट एंड देन वी विल सॉल्व फ्यू प्रॉब्लम्स. ओके, सो थैंक यू वेरी मच.